Hi John, this is Thomas Hanaho for CA3 multiplayer. I'm going. Patrick mentioned that you thought that the screencasts were a bit long last time, so I'm going to try to shorten it up this time. So this screencast, I'm going to be talking about how we did the team dynamics, what I did particularly, latency, jitter, reliability of network, and then just give a brief overview of how the client and the server works together and that sort of stuff. So, how we did, I think we did pretty well, considering. I think we had trouble with the last CA. The CA I think went a lot better. Like we all sort of were able to get into the code and sort of figure some stuff out. So yeah, I think it was okay. And then I was happy enough with the game that we were able to show off at the end. I would have preferred if we had gotten some more progress in it, but that's we'll just have to sort of take what we can get. Um, Moving on to teamwork. So in terms of teamwork, I think the team worked well this time. I think it worked better than the last two times, definitely. Um, I felt yeah. So I think me and Patrick worked really well. I think I think Zillan sort of let us down a little bit. I think Patrick thinks the opposite, but me personally, I would sort of feel like I would focus. I would want to work with someone who's really reliable, but also and someone who puts in like time more than actual like results. So like I felt like if you can see on the gits that like Zillan only really sort of did stuff until the end. Until like the day before or whatever. But I'm not sure what his time scales was. But whereas me and Patrick were working on this for like the last week or so. Um, yeah, and but yeah, we'll move on. But yeah, working with Patrick is really good. I always like working with Patrick over the last 4 years. So, but yeah, it was working with Patrick was good. So okay, right. Well, I'll go through what I did first. Next then. So the easiest way to do this is just to show you Git. Um, So the first thing I did was added bugs to a bugs list. So this time around, I wanted to sort of learn as much as I could. So to do that, I made a bugs list which detailed all the bugs that I came across over the course of the last week and so. So I made the first thing I did was I added a bugs list and sort of detailed. I added to that over the course of the project. The next thing was reduce the number of mines in the game. That was just a simple case um, of changing the value that you send in to generate mice. I'll show you that. I'll show you all the code in a minute. I'll just go through this first. So I updated the mine positions. So first off, I moved the mine positions around so they're not random, and so I reduced the mines from 20 to 10, and then I changed their positions. So then I cleaned up the server code that was just general admin stuff there. Um, I adjusted the player starting point, so the player starts at the far left-hand side of the screen. I think in the demo we saw that all the players are starting at the far left, but also the top, and they're sort of getting stuck. So that would be something to improve upon later. Um, then I added to the bugs encounters list again. I adjusted the kill. So I changed the damage, or I changed the setting of the damage so that when you ran into a mouse or a mine, in our case, instead of getting an additional point, what you did was you got a point taken off your health. And originally, what I did was when you hit the mine, you would get insta death, but we changed that after Patrick decided no, that wasn't good enough. So then at this point here, this is where we're getting into the issue with the /c or the xcopy files, and that's so that was an issue. So I updated the bugs list, and when I got that working, um, updated the README. Um, yeah, this is at this point Patrick asked me to put damage back to 1 because he thought it was too difficult in the game, and we agreed that yeah it was. This here is related to the mines. So at this point, before here, like roughly around here, I was trying to get the mines to float up and down the screen, so it was harder to miss them. But then we decided that we just use set locations for the mines and leave it at that. And that's what reverting to old top and down layout of the mines. Um, updated the README again, and then added in persistence logic. So we wanted to get persistence working. Fortunately, we couldn't get persistence working, but so that was just me adding in the persistence logic document, which I'll show you to you now. And then I updated the document, and then the last thing I did was I tried to add in my persistence code, and then I had to revert it because it caused issues. But what I'm going to do is I'm going to show you, I have two separate projects, and I have one with the persistence code and one with the base code that we actually showed to you in class today. And then I'll go through all the code that I did. So, okay, so we're good for time. So I just want this to be 15 minutes long. So I'll just quickly show you the documentation, I think. So here's all the documentation that we made. So the first thing that I made was a client, just images, like initial setup, because I know like previously one of our problems was that we had issues just setting up the actual project, so that took like a few days to figure out. So when I got it working, what I did was I actually just took screenshots so that if anyone else had trouble in the team, that they could just see this very easily, and then it comes up to this, and there's a brief thing. So I think Zillion use that later on. Then we have a brief market scheme, bugs encountered. This is Patrick's slide notes. So Patrick made notes pretty early on about the slides when we were starting off the project. This is just steps on what we should do with the game. Persistence logic. This is my logic for persistence. So that's the file that I made before I started coding. And then the bugs encountered. So this is what I worked on over the few days. So I came across 3 major bugs. I think this is open already. Yeah. So I'll show you here. So what it does is just tells you what the document is. It describes each bug, and then it tells you what the fix was, and then it'll go through it there. So like the last bug that we had there, bug 3, which was the X copy. Like I'll tell you what the bug is. I was having trouble with it, so I took a screenshot of the error, and then right down here it shows the fix. So this is where you came in with your /c. So actually later on, Patrick had the same bug, and it was really easy because I could just show him this, and I'd say, here, take this, copy that in, and and it worked straight away. So that saved some time. Okay, I'll go on to code now. So in mouse, so git request, mine positions is in server create random mice. So right here, this is your original code here for the mouse, and it's a set position. What I did is I set up a for loop for all the mice, and then based on the number of mouse, you set a different position. So this is just setting the mice in the different positions into like 1, 2, 3, 4, 5, and 6, and so. Then the next thing that is player start position is in spawn cat for player. Yeah, is here. So what I did here was I just adjusted this, and so I just changed from, you can see here that it's the x-axis that's changed in the original one, and I just set that to the y-axis, which is pretty simple enough. Yeah, and then the persistence. So those are the 2 things that I worked on. There was other small things that I worked on, but I'm not sure, can't remember most of them. So I'll go through persistence now. So this was the big thing that I was working on over the last week. And so how I wanted this to work was that at the start of the game, the server would check a file and then see if there's any values for high scores in the file, and if there is, put them into a vector. And sorry, I'm just conscious of time, so I'm just going to say this quickly. So they would put them into a vector, and then it would iterate through the vector, and then so it would make a vector of strings called out vector. And so this method is called not in run, or actually I think it is run. Yeah, it's at run. It will call the method read in high scores, and it will read in all the strings from a text file and then put them into a vector of strings. It will iterate through the strings and then make high score objects from it, and then it will and then it will go through the high scores, and then if you played a game, you won't have a high score. But if you close the game and then you reopen the game, it will check your play ID, and it will check the player IDs of all the high score objects, and then if one matches, then it will send the high score number from the high score object to you over the server. And yeah, that's how that worked. So how far I got was, so this code here that you'll see. So I was using code that I wrote for a C++ assignment for the text-based game that you actually saw before, but just in case you want to look. So the way this works is it actually works different the way I had it, because I was trying to get this to work, didn't get to work. So I used this as a reference, didn't get to work, but I used this way here. So what it does is it just creates two files and high score as an example, and then the first iteration what it did was it would read in all the strings, and then it would output all the strings to another file, and that was just to prove that I could actually, when someone left the game, that I could update the file. So that's why I did it. But after that, what I did is I just took went through the files, got every single line, and put them into a vector, and then close the file, and that's where as far as I got that. So that's pretty much all the code that I wrote for it. So next I'll quickly go through the stuff, the latency and thing. So the next things that I'm going to talk about are the latency, jitter, reliability, client, and server. Okay, so latency is the feeling of how responsive the game is to the player. So this is like if you can tell that there's lag or anything like that. How to test if what the latency is like. How you can do this is you can put a timer on a packet, and then and what you do is when the packets come in, then you would say if the timer hasn't happened, then you don't update every single frame, and this basically puts a delay on it, which would show the latency. Now, if I just find it difficult to try and find the actual methods where that would happen, or make a method to do that myself, so I haven't actually been able to do that, but I sort of know the how to do it. The next thing would be jitter. So jitter is the variation in latency. So the difference between jitter and latency is that latency is if you have a delay of like 5 seconds, but it's constant. So it's like 5, 5, 5. Jitter would be a variation in that delay. So jitter would be 5, 0, 3, 5, not minus 1, but like 1, that sort of way. That's the difference there. How you could show that in this is that if you added a randomized to the delay. So like every time you hit the delay, you could have like a random generator number between 0 and 10, and then that would set the delay for the next number of frames that you would update the packet at, or not the number of frames, but like the number of packets that you would lose. So then the last thing is to do with packet loss. So packet loss is to do with the reliability of the network. So what we're actually using is UDP. Sorry, no, we're using TCP is the. Sorry, yeah. Let me think. Yes, we're using a UDP network. TCP is a good one, as in it's very reliable, but in this sense we don't want it to be reliable because we don't want to have every single packet. What we want to have UDP, which will drop packets if they're unnecessary. So packet loss is one of the things that you can show as well, and it would show that based on the number you could drop. You can set the packets that you want to drop. And lastly, I'll just show the relationship between the server and the client and the main file. So we have three projects here. One is the server, and one is the client, and one is the main file. So the relationship between these is that the server, the RoboCat project here is files that are related to all of like both client and server. Server is the computer that hosts the game, and then so server is the server that hosts the game, and then after that you would open up the client, and the client is how the user actually interacts with the game. So the user will have a client which will interact with a server, and that's how they will play the game. RoboCat is designed in sense of what files are related to both, and then that's how that works. So I'm just going to ran out of time there, but I'm just going to continue on the next. I'm going to make